So there are two more processes of thermodynamics that we need to talk about. They're not really as important. They don't really show up that commonly on a test. The first is an isothermal reaction. When we talk about iso, we're talking about something that doesn't change. Thermal is obviously referring to temperature. So if we talk about an isothermal reaction and we go back and look at the equation for the ideal gas, PV equals nRT. So if temperature remains constant, that means that if a process is happening where the pressure is increasing, then the volume has to be decreasing, and vice versa. So if the volume was increasing, then that means the pressure has to be decreasing. That's an isothermal reaction. To show it on this graph of pressure versus volume, our isothermal reaction will look like a linear reaction. It's a straight line. Okay, either that way or this way. Either way, it's an isothermal reaction. The importance that you remember is that the temperature does remain the same, so that really nothing is getting done in an isothermal reaction. I mean, stuff gets done, but it's not that important. How can I put this the best way? If you think about it, the temperature remains constant, so the average kinetic energy per particle is staying the same. It doesn't necessarily mean that work is not being done or heat's not being transferred. It just means that that object is experiencing does not experience a change in its kinetic energy. Okay, that 3/2 over k, that 3/2 kT. But that is an isothermal reaction. So you can still see that there can be energy being delivered in the system. It's just not being delivered by the isothermal reaction. If I had an isobaric and I had a isochoric, there's still being energy being delivered. Okay, but isothermal means that there's no change in its average energy. That 3/2 kT, that still holds true. Okay, cool. Now the last one is adiabatic. Adiabatic is a kind of an interesting system. Adiabatic means that there's no heat flow in the system. That means that there's no exiting or entering of heat flow, and it's a slow process typically. When an adiabatic process happens, you're just basically allowing the system to behave normally. So, you know, the whole idea is that nothing really is, there's no really external influences going on. Okay, so when we talked about isothermal, there can be external influences. When you talk about isochoric, there most certainly is an external forces going on, or external something going on. When we talk about isobaric, there's an external system going on. I'm delivering work, or work is being delivered to something outside of my system. Where isochoric, something's delivering heat or removing heat from a system. When we talk about isothermal, it's very difficult for an object to maintain its exact same thermal temperature. So you're being very careful and very deliberate how pressure and volume are changing. Now, adiabatic doesn't care. It's just allowing the system to expand or contract normally. So when we see an adiabatic system, we see a system like this. The importance about that adiabatic system is that there is no thermal energy being introduced. Now, all I would really care about is that you understand what adiabatic means. There's no heat entering or leaving the system. But it's not important for the test, or any test, because you probably will not see an adiabatic problem. I have yet to see one.